Interesting question here. Point P is chosen at random inside a square, could be anywhere inside. What's the probability that RPQ is acute? So I think a good idea is to just try using some values of P. Sorry, yeah, putting P in different places. So that would be acute. Remember, acute means it's less than 90. If we go sort of over here, then yeah, that would be less than 90. If you go quite close, then no, that's going to be obtuse. So we're kind of looking actually for where it's going to be 90. That's going to be our boundary because it's going to go from being acute to obtuse at the boundary. And if I draw in a diagonal, then that will immediately give me a right angle here. So I know that this is going to form part of my boundary. And it seems like if I go over here, for example, like inside this triangle bit, then I'm definitely going to be, yeah, that's going to be obtuse. So is that triangle the one? Well, if I go over here, that's looking like it is beyond 90 as well. So it's not enough for the diagonal. And this is where we need to think about one of the circle theorems. And actually, it's the angle in a semicircle circle theorem. So if you have a circle and you draw in the diameter, and then you draw a triangle, then this will necessarily be a right angle. So if we make RQ the diameter of a circle, let me just bring this to the front. Okay, so I'm going to go for the midpoint of RQ, and now I'm going to draw a circle. You have to judge it where the midpoint is. I'm not, don't do it, don't worry about doing it really precisely. And I'm doing it precisely, but you can just sort of draw a semicircle. You can see I haven't quite hit that middle bit. It wasn't perfect. But wherever now I put a point on here, for example, like on that semicircle, I know that if I connect up Q to R, so if I put P there, for example, that would be 90 degrees. So we've gone beyond that triangle, actually anywhere in here and here and here, we're going to get an obtuse angle because the boundary is the semicircle. Okay, that's where it's 90. Inside, it's going to be more than 90. As soon as you go outside, even to here, it's going to be less than 90. And we're pretty much there with the problem. So let me say that this length here is 1, so the square in total is 2. Then the area, this purple area, is going to be pi times 1 squared divided by 2, which is just pi over 2. So that is the area that I'm in for us to get an obtuse angle, or on the very boundary, 90 degrees. And then I'm going to need to divide, if I wanted to find the probability, then I would divide by the total area. So it would be pi over 2 divided by 4, because that's 2 times 2. So I'm going to get pi over 8. Just to say again, that is the probability of me picking a point P inside that semicircle. And therefore, if I want to go outside the semicircle, this region here is where we're going to get acute angles. It's going to be 1 minus that. And therefore, our answer is E. Brilliant.